Welcome back to Science in VR, brought to you by OSGRAV. OSGRAV is the ARC Center of Excellence for Gravitational Wave Discovery. Today, we are going to explore the sky in multiple wavelengths of light using SYVER. Now here we are back at our main menu. What we're going to do is we're going to look down and choose the icon that says All Sky View. When you get here, you'll be able to see the Milky Way in visible light. So take a look around and enjoy the view of our Milky Way. Now let's explore some other features here. If we go back to our menu, you will see that there's an option to add constellations. When you do this, what it will do is it will add the constellations that you may be familiar with in the night sky to the scene, so you can see where they are with respect to the disk of our Milky Way galaxy. Next, when we go back to the menu, we are going to explore what the Milky Way looks like in different wavelengths of light. So after taking a look here at it in visible, or the optical wavelength of light, we are going to choose a new wavelength because different wavelengths give us different features. We will click on the word that says gleam. This will give us a view of the Milky Way in a radio wavelength, and as you're going to see, this is going to give us some different features of the Milky Way. Because radio waves have a different wavelength than optical rays, it will provide for us different features. So using different wavelengths of light is one of the ways that scientists are able to investigate different features of what is in space, because different objects emit at different wavelengths. Now what we're going to do is we're going to click the button that says Special Objects. This will bring up hotkeys in our field of view. If we click at the one in the middle that says Sagittarius A star, this is a close-up of the center of our galaxy in this radio wavelength. Now we can look at what the Milky Way looks like in some other wavelengths of light. By clicking on radio waves, we're able to see the galaxy in a slightly different wavelength of light and see how those features change. Moving higher in frequency but shorter in wavelength, we now move to the cosmic microwave background, and you can see some of the variations in this that indicate the makeup of the universe at early times. Moving on to microwaves, here we get a different view of our Milky Way galaxy. Notice how each of these wavelengths provide for us different features, and this is why scientists use multiple wavelengths of light to study. Back here at optical, we are going to look straight up until we see a special object in the sky called M87. This is another galaxy, but this is special because it was the first direct image of a black hole. You can read a little bit more about it here. Now we are going to go back down to our menu, and we're going to explore some of these other wavelengths of light. You can take the time to read some of the details. Ultraviolet, X-rays, and gamma rays are all going to have shorter wavelengths and higher energies than optical light. As you can see, they allow us to see different features, and these are going to be some very high energy features of objects in our galaxy. Now we will head back home. Here we will take a pause and go online to look at some of the additional materials that OSGRAV has available to support your understanding of these topics. Once again, let's go to our Science in VR website at SYVER, that's scivr.com.au. Here, again, we will scroll down through some of the materials about our public events, and let's get down to where we have additional resources. Here you can see we have a kids fun sheet for light in the EM spectrum. So if we go ahead and click on that, it'll download this fun sheet. Once again, we have a word search, a maze, some materials to color, including a Parkes telescope, and And finally, a crossword where the answers are hopefully obtained from engaging with the Science in VR app. Going back to our Cyver website, we will once again go to our teacher's assets, and if we go there, you'll see that we have a light and the EM spectrum. So what we'll do is we'll download those activities, and they're going to open up once again as a zip file. And if we give that a moment to open up, we'll see that again we have a student, a teacher, as well as slides for presenting this material. All right, so thanks so much for spending this time with us, and we look forward to bringing you to LIGO in our next video.